Hello everyone, it's March 21st. Okay, let's get down to it. What do we have today? We have the smallest string, whatever that is. So the goal is trying to finish that one. Forgot to complete yesterday. Yeah, so the goal is to finish the challenge first, and then I'm gonna go back to the longest substring thing. Yesterday we tried. Right, we have a segment tree solution, but it timed out. I didn't think of anything else. I was trying to reason with it. I think the problem is just because it's just too long, and then O1 login is not working. So I'm gonna look at a second hint. So yesterday we looked at one hint. So today I'm gonna look at a second hint and try to see if we can solve this. But back to this first. Smallest string with a given numeric value. The numeric value of a lowercase character is defined as its position in the alphabet. So the numeric value of A is 1, B is 2, okay? The numeric value of a string consists of a lowercase character is defined as the sum of characters' numeric values. For example, the numeric ABE, okay? You're given two integers. Return the lexicographically smallest string with length n and numeric value equal to k. Now that the string x is if y, if x comes before y, or if I is the first position such that this and then xi comes before yi in alphabetical order. Either x is a prefix of y, or if but now the length is the same, so it's basically we have to say if I is the first position such that it's not the same. Yeah. Okay, so AAY, numeric value is 27. It is the smallest. Okay. So what we want to find is the smallest, right? Let's try n equal 1, right? If n equal 1, then the smallest is whatever the k decides, right? Now let's say n equal to 2. If n equal to 2, then again it's n equal to 2, we say n equal to 1 is going to be 1, it's going to be A. Not A, n equal to 1 or whatever that dictates. Depends on the dictation, right? So if 2, K, right? K is the value. So if n equal to 2 and then K is, let's say, 27, right? That's 1 and Z, A and Z, right? If it's 28 and then we do A, it doesn't work. So what it means is we need to try to fit as much A as possible in the front. Hold on, let me think. So it's like what? We set the first one if it's 1, and now we have remaining. We try to find the maximum. No, the minimum. Oh, we set the first one. It could be like impossible, right? If it's 28, and then we set first one to 1, then it's impossible. So the first one has to be a B, right? What can have an impossible value? Impossible value is if it's larger than it's all z, right? That's impossible value. So if we set first one to a, we see if it's impossible. If it is not impossible, then we can set a second one to a, see if it's possible. So in this case, we set 2a, right? That gets us down to 71, all right, 71. And we say I have 3 left, 3 positions left. 3 times 26, that's 78. Okay, so what if we set another one? Then we have 70 left. And 2 times 26 is 52. That's too much. So this one cannot be A. Then it has to be B. It should be anything that makes it work. It should be anything that makes it. So you're gonna be all A's, right? And then when they've had A, and then it's not enough. So because the remaining is 52, but we have what, 70, right? We have 70, right? We have 70. We need to fit 70, but now we have 52. So in this case, we want to find the smallest here, because if we find anything bigger, yeah. So the smallest. So we have 52. So basically 70 minus 52, it's 18. And 18, I think it's S, right? 18 is S. Yeah. So what do we say? We say the remaining value, right? The remaining value. So we go from front -1, and then we calculate the remaining, see if it's possible. Actually, we're gonna go back and say, like, first one I do 26, and if it's 26, then the value is 73 minus 1, 2, 1, 2, 3, 4 minus 4, right? 69. So, and then we go 52. That would be 70. Right? And then we do. I don't like that. I like to go from front to back. But we can do K. So what we want, what do we want? I think it's gonna be, I'd say, m number of A plus some letter, then plus n number. When I say x plus some letter plus y times 26, need to be 7. Need to be a k, okay? And then x plus y plus 1 need to be n. Then we solve this equation, okay? So what we see is x equals n minus 1 minus y. So n minus 1 minus y plus the letter in the middle plus 26y equals k. So we have 25 times y plus the letter equals k plus 1 minus n. And y is the thing we want to know. Letter we can try, right? So okay, just minus letter, and then it has to be divisible. So we just try one by one, right? Try one by one and see the first one. All right, so we want the letter to be small. So letters go from 1, and the first one can make y work. Then we get it. make y work. Okay, and also, so this has to be divisible, and this has to be larger than 1, right? So this has to be larger. Well, it will definitely be larger than 1. Okay, let's give this a shot. Oh, I should do 22. All right. So we say y equals 0. I don't know what y equals. Okay, I'm gonna say for I in range 1 to 27, right? And then we say if k plus 1 minus n minus I mod 25 equal to 0, the first one, then let's say div mod y and the remaining equals div mod this on 25, right? So if r is equal to 0, the first time r equal to 0, then break. Okay, then we're gonna, what do we return? The thing. So we return a, and then we have I, right? We have I. So we're gonna return a times n minus 1 minus y. Yeah, I don't think we need to do this because y will be defined no matter what. Plus char I. So I minus 1 plus 97 plus z times what? Times y. Okay. All right, let's try this. This case, 3, 27 shall give us AAY. Okay. What's the next one? Next one is 5, 73 shall give us AASZZ. NK. Get smallest NK. Okay. So it passes. I don't know. For fun, is not a valid value of integer. Oh, it has to be valid. It has to be valid. Oh, all right. I'm not gonna test this. Okay, we test like 24. A simple case. Yeah. All right, let's try this. Oh, I've done this before. What is this? Oh. But it should, right? Hold up. It doesn't feel right. I thought we got it. Okay, where do we go wrong? We say x plus letter plus this equals k. That's true. X plus y plus 1 equals n. X can be 0. That's the thing. X can be 0. And I ranging from 1 to 26, right? 1 to 26. So last one, I is 26. Let's see, k is 130 plus 1 minus n is 5 minus 26. Yeah, it can be divisible by 25. Y equals 4. Huh? That's interesting. Y shall be 4. Y is 5. How? How is Y 5? And I is 1. I is 1. Oh, what is 5? That's negative 1. Oh, I didn't know that. A times negative 1. Yeah, even if it's this, I is 1. Oh, this one nothing. This one goes. The one's in the middle. Okay, so if r is equal to 0 and n minus 1 minus y needs to be larger or equal to 0. Yep. We add another constraint. Alright. So we add another constraint. Let's see. There we go. That's good. Look at this. I must have used some, I don't know, convoluted way. And then I realized I can do it this way. Pretty smart, I think, this time. Yeah, I think it's a good question. 1663, right? So this problem can be solved mathematically. The best way to set up the string is to get as many A's as possible. All right, and then when no more A can be added, we add some letter, and then following that, and then the remaining will all be Z. Yeah, that's the only way, because we basically find the smallest that make it possible to fit the entire thing. We find one more letter, one more smallest letter that can make the string work, which results in the remaining letters all being Z. One trick is to check for, so we can check the intermediate letter from A to Z and return report, right? The first letter that can make the string possible. Know that during the check, we have to also make sure the number of A remains non-negative. And that's what I got it wrong. That's 0.26, that's 0.1, right? 32 milliseconds. I think I hit 98%. It's not bad. All right, so this is my initial solution, which is, I don't even know how to do it. Wait, that's a smart solution. No, that's a slow solution. Cumulative sum. What was I doing? If it's smaller than 26. I'm filling Z. If it's smaller. Yeah, it's the same. I have the same idea, just I didn't realize I can use the mathematical way to do it. And this is the math way. Oh, look at this, a div mod directly. That was even better. Oh, we have the idea. Yeah, this is actually better. So yeah, we have 25 to fill. So we just do this 25, and then that's number of Z at the mid value. If mid value is 0, that's just basic. That's an A. That's even better. All right, so that's that. I think I did pretty well. All right, back to the struggle. Hint number 2. We need each segment tree node, so the length of the longest, only one repeating. Yes, I have that. Now the leftmost and rightmost character Max length. I'd have that. I did. I think this is exactly what it is. But it timed out. I don't understand. I don't know. Hmm. 5 milliseconds. You want to try again? And nope. I think it's still not good. Yeah. Where can we improve? They're saying we're doing too many comparisons. Okay, we're doing copies. How about we don't do copies? Okay, let's just try we don't do copies. And this is fine. This is just checking, right? So if this and this not equal to this, so node shall equal to okay. So how about this? We'll say node 0, node dot l count 1 equals this 0 and node dot left dot l count 1. How about this? Right? We use this trying to avoid copy. And cross and we're gonna merge. So we never create a new one. We always okay. Let's not create a new one. We always fill in the old ones. Well, it's fine, fine by me. So these should be R. Right? Yeah. Now we don't do this. We write it out. And this is wait, hold on. Yeah, write it out. And cross equals this. So now the left continuous. So it has to be a cross. Right. Okay. And a right with cross. Oh shoot. Forgot this. No copy. No copy whatsoever. Left. Where's the right? Damn, that's just my eyes are crossed. All right. Okay, so no copy. We didn't do any copy. And how about this? Build. Yep, let's also don't copy. Right, no.l l count 1. Yep, no copy. Don't do any copy. No copy, no copy. Don't do copy. No, we can actually update. Yeah, that's fine. Okay. Ooh. The heck? Oh my god. Okay, something is wrong. I think this else is wrong. Yeah, it should be copy. It should be no cross. Interesting. Okay, this is not left. This is right. Oh my god. How many mistakes did I make? Oh wow, I made a lot of mistakes. So these are right. This is supposed to be right. Left, left, left. Left, 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 right, right. This is supposed to be right. Both are right. This is right. Okay, try it again. Left, continue, you go to right. Left. Continuous, cross. Right, continuous, cross. Right and left. Left, left. Left, left. Else, cross equals this. Left, left. Now right, right, right. I don't see the problem. I don't know, I have to copy this back. Let's do it again. Oh, one more time, one more time. I don't know where I got it wrong. Alright, this is correct. Let's do it again. Alright, so we'll copy. So basically it says 0, 1. Right, as a 0, 1 equals this 0 and this 1. Okay, that's fine. And this one, 0 and 1 are equal to this one, 0 and 1. Right, that's fine. Okay, here. Again, 0 and 1 equal to this and this, right? 0 and 1 equals this and this. Yeah. Okay, so this 0 and 1 equal to this thing, 0 and 1, and this thing again, 1 equal to this, right? This 1, 0, 1. Okay. You know what would be the, like, you do this and we still don't pass. That would be very tragedy. Let's hope that doesn't happen. Okay. Last one. Okay. Okay. All right. Whatever the reason is that got it wrong earlier, I don't want to know. Let's say 5 seconds. Let's see how fast we can do this without. I don't think that's the reason, right? 4 seconds. I don't know. Still feels slow. Nope. Maybe did I move on a little longer? 48. Oh, I just gave you the test cases. 51. It is faster. Okay. Now what? This one's 51. Don't tell me that. don't believe that's the reason. I refuse to believe that's the reason. Maybe the key is to reduce some of the checks. I mean, I have 4 checks. Maybe they can be combined. Okay, let's see if left is the same. That's still the same. The difference is hold on. If left all the same, okay, and we say, what's the difference between this and this? If right is all the same, right always be like this. Only difference is in here. If they're the same, then right becomes cross. It's the only difference. If you take a look at these two, that's the only difference. So that means we can say if they're not the same, we do this and this, but we don't do this, right? And we do this and this. That's the only difference. There are police officers outside. Alright, so what we say is we're gonna make changes. So we say this, right? We don't need. Okay. And we have cross. Right, so if this, don't do this, do this and this, and then this is the final one, and they will equal to cross. So you're always equal to the right count. Yeah, left is all the same, so left and cross. And right, on the right hand side, it depends, right? If it's cross. Left is all the same. When do we do cross? If they're not the same. So if cross is 0, right? If cross is not 0, then we shall do cross. Okay. So basically, it's the same for both, right? So yeah, I think it's the same for both. We capture the cross first. And it equals cross. If cross, else this. And the same thing. If cross, else, well, that should be right. And the right content. So we don't need to do this. So basically, if left is all the same, then we say if this is not equal to this, then cross is 0. If it's equal to, then cross will equal to the left plus right. Right? And then left content will equal to cross. Makes sense. If cross is not equal to 0, how about the right? Nah, I shouldn't do cross. It should be if cross and this, right? The cross and is this. If a cross and all right is the same. So we use this to remove this. Okay. Then this will be else. Then it's the mirror image. I think it should be the mirror image. So what I think it should be just else. If so. If left is all the same, we can actually say elif is right all the same. So left are the same, we have this and this. And left, oh, hold on. Else is left is not the same. Then right can be the same or right cannot be the same. So I have also two situations. You know what? So else, so this is an else. Right? Now we try to compare. We check. Okay, so the same thing. We say if they're not the same, then cross equals 0. Otherwise, we can compute the cross. So the cross is always the same. Look at this, the cross is always the same. And after that, we can compute. See the left is all the same because left there's no cross for the left because the left is not the same, so left cannot cross, right? So left cannot cross. Now right can be cross or cannot be cross, so we need to do right. So right equals this, but we have to do cross, right? Cross, if cross and is all same else. Cross is 0 and right all the same, and then right can add cross, otherwise no. Right, so that's that, which I believe we can comment on this. Yep. Okay. It feels like we can further simplify, because if this and this, the computation for cross is the same, right? So what we can do is this is the compute the cross. No matter what, this is a cross, right? And then we say this and this. So we get a cross. I mean, we can even say cross equals to this. It's true. It's not equals to. Right, so equals times this. Right, we can say this times this. So if it's true, then we do this. Otherwise, no. So that's the cross. We can get a cross, and then we see if cross and is left all the same. So I believe it's this, like this. So we can remove all these as well. Okay. Do you think this is going to make it simpler? Not sure, but let's give it a shot. All right, let's try it. Doesn't seem to be faster. Oh, this seems to be faster, about 900 milliseconds faster. Short circuit. We can short circuit it. Here. So is left all the same as this thing. Alright. So this whole thing, we can put it in and allow it to short circuit it. Hold on. So cross is computed this way. And we can say no.l count. This is always .left.l this is no change, and then no.r 0. Always for no.right .r count 0. So this is no change. And then we say, so I've crossed off this. And we say, right, this equal to cross if this, else this. And then also I don't do this, 1 equal to cross if cross, and right all the same. Right, else this. So we further remove these two. Okay. Not sure, but hopefully. Try this one. If we can get down to like 3,000, then I have a higher confidence that this might work. We're down to 3,000. Well, you see left equal to, oh, it's different. Try this. Come on. Come on. God. No, we're stuck at 51. Alright, I don't know. Maybe we should do 6 values. Alright, I think I'll just continue this tomorrow. Okay, so instead of using a tree node, and how do you do left and right? Index. Oh, I see. All right, we'll try this tomorrow. All right, that's it for today. See you guys tomorrow. Adios.